little time has passed now, and I've completely epoxied on the first two centering rings here. I've also attached the shock cord, and I've stuffed the length of it down here inside the motor mount. But we're coming up on the point where we're going to glue this into the body tube, and this will be the last chance we have to make any changes to this assembly. Now, one other thing I did was take my third centering ring. I drilled two small holes through it and then ran a short length of Kevlar string through here. It doesn't have to be Kevlar, that happens to be what I had on hand. And this way I can place this over the motor mount and still use this to keep the mount straight while I'm gluing it in. But then I can also pull this back off using the string, so that once I've got this in and I'm gluing the fins in, I still have access to the fin tabs inside. Okay, so I can now stick this in, and this is just dry fit right now. Okay, and this is going to go to right about there. And then I can stick this back piece on to help keep everything aligned while the epoxy sets on the mount. And then when I'm ready to put my fins in, I can take this back off, and I'll be able to make some interior fillets on the fin tabs. Okay. The other thing I've done is sanded around the aft end so that the motor mount retainer will stay on. And I was debating between the R.E.A.R aluminum retainer and the Estes plastic one here. I ended up going with the Estes mainly because it arrived first. I ordered both, and the R.E.A.R one is still being shipped. And so this will just fit on here and will be epoxied on. And so when everything is assembled here, the motor mount will stick out about that far. The other centering ring here will go just to the edge of the fin slots here and be another attachment point for the fins. Okay. One other thing I'm going to do before I put this in is I've got this knotted on here fairly well, but I'll also add a little bit of epoxy around the knot just to make sure it never comes off there, because we certainly wouldn't want this to come out. If you've used Kevlar for small rockets before, it's usually much thinner than this. So for really lightweight rockets, I use this. This is 2,000 pound test Kevlar, and I really don't need that heavy for this. I probably could have used 300 pound, which is what I use in most of my mid-power rockets. But I wanted to just test this out and see how it was to work with, even though this rocket really probably doesn't need that much strength there. But this has got 2.2 meters of Kevlar string here, Kevlar cord, and the 2 meters is nominally what I would have for the shock cord. The 0.2 part is to account for the knots and the part that remains in the body tube, things like this. Okay, but generally with Kevlar you want at least 3 times the rocket length. Alright, so I'm going to go ahead and just fold that back up and put that in here. Okay, I have some epoxy made up now, and what I'm going to do is first put a layer of this up inside the body tube, up here beyond the slots, and you got to have kind of a balance here between patience and speed. Do this fairly quickly. Okay, hopefully see I'm getting this right up just beyond the fin slots, so that when I push this in, it'll force the epoxy ahead of it and make a nice fillet in front. Now the middle centering ring is not going to have a lot of adhesive. It's there mainly for spacing and additional support. When we go to glue the fins in, though, we'll be able to put in a fillet on the aft side of it at least. And so it's not going to be completely unsupported. And the front one's kind of the opposite. It's going to have a big fillet on the front, but it's not going to have much in back, simply because we can't reach it. And if you happen to drop a little bit inside there, lower down, it's okay. It'll get forced forward. So even though this looks kind of haphazard and messy, it will all come through, and it's very necessary, as this is where most of the force of the rocket's thrust is going to be applied to the body tube, is on this forward ring. Alright, so there's a good layer all the way around. Okay, now, before I put that in, I almost forgot, I do need to put some epoxy on my shock cord here. Just glue that knot in place. Now I do want to be careful that I don't get it all over there. And I'm trying to keep it off the eye of the eye bolt there, just so it can move across there. Okay, so now I'm going to slide this in. Okay, now I've hit the epoxy. It should go to about there. I'm going to use a fin now. Check my clearance. Move that in just a little bit more. Okay, and I can back it off just a bit. Just make sure, bump that down. Okay, so that fits all the way around. Okay. And as I suspected, we can't really see much on the back of that middle ring. I can see some air gaps. And one of the things we can do here, I'm going to wait until this first epoxy hardens. Whoa, that's moving. Okay, so look around in there. I've got a little got up on the edge here. I don't want that. Okay, but I'm going to just let this sit and harden for a while. I should have been wearing my gloves there. And so this is where I can put on the aft ring. Okay, so I've got that aft ring in, it's just sitting there. And now I want to make sure that my fins all still fit. It's starting to harden up there. There we go. swirl around. Okay. So now that's going to be set aside for a little while and let the epoxy harden. And then we'll come back and start putting in some fillets and filling in what we can, and then put the fins on. Okay, I've removed the rear centering ring again, and we can see down inside here. Okay, everything's nice and straight. And so the next thing we're going to do is start putting the fins on. Now, something I've noticed here, if we put this on and look down, there is just a little bit of a gap between the edge of the fin and the motor mount there. And this is true for all of them. Okay, so just a little bit of difference in tolerances there. So what we're going to need to do is make sure that we've got good epoxy fillets there. And what I'm going to do is tack these on first with some gel type super glue, let those dry, and then put the epoxy on. And that way they won't be trying to shift around as we're trying to work the epoxy down into the fillets. Alright, so I just tacked on this fin with some gel type super glue, and the gel type will fill in small gaps in here. And we did have that gap just a little bit between the root tab there and the motor mount. One of the things I really like about through-the-wall fins, in addition to the strength, is it's easier to put them on straight. And if you end up, for whatever reason, have slightly crooked fins, at this point you might be able to break the super glue, but probably not easily. But even if they're a little canted one way or the other, it's still going to fly without much problem. While the glue on the fins is drying, I'm going to come back to the nose here. And remember that I had put in a threaded rod that's epoxied down inside. And this allows access to the interior of the nose in case we need to add weight. Later on, if I wanted to put an altimeter or some other payload in there, we could do that. And then this is held on by this female-to-female coupler. And then what I did is take an eye bolt here and I cut off about half the thread length, and that's going to go in here like this. Okay, so what I'm going to do now is use some permanent thread lock to put the eye bolt into the coupler bolt here, or coupler nut, and then that will become one assembly. And I'm going to put a lock washer in here to keep this on, but still allow me to open it up when needed. Alright, so this is not actual permanent, it's semi-permanent. If you really want something that's as close to permanent as you can get, you could use epoxy on this. But I still want to be able to take it apart if I need to. So I'm just going to put a little bit of this on the threads here. Alright, and then screw on the coupling nut just to the point of the threads there, and that leaves me just a little bit over half the depth. I don't think you can see that in focus. And then that can go on to the threaded rod here. Okay, so the super glue is dried here, and it looks pretty straight. This top fin is canted just a little bit. The video actually exaggerates it more than it is, but I'm not going to worry about it. It's such a small deviation there. It's just enough to be noticeable. Probably not worth breaking off the super glue and trying to re-glue it with all the debris in the way there. Okay, so what we're going to do now is use some 15-minute epoxy instead of the 6-minute that we've been using, or 5-minute. And the reason for that is I want to be able to flow it down. So I'll start at the top, which is actually the bottom, but start at the edge of the fin here and just flow epoxy down on either side of it, and then have it collect against that centering ring in there. And that will help reinforce that middle centering ring, as well as reinforcing the fins. It'll also give me a little bit more working time so that it has time to flow down in there and get into all the nooks and crannies. Okay. Here, about a popsicle stick sized applicator would probably work better, but I don't have one. So I'm just going to make do here. So by the time I get done with this, I'll have fillets on either side of the tabs against the motor mount, and then also inner fillets on the underside of the body tube here. So both contact surfaces there with the fin tabs will have epoxy. And I'll probably have to do this in more than one batch. So I'm going to continue this, and when we come back I'll have that part finished. Okay, so I've got the interior fillets poured and in place, and then I went ahead and put in the aft ring because I was getting some epoxy up along the edge of the tube of both the body tube and the motor mount, so I went ahead and just mounted that to squeeze all that down where it belongs. And now I'm mixing up another little batch here, and that's going to be put in along the interior here, so along the edges to reinforce that. And then I'll also put in the motor mount retainer here on this. And mainly I'm doing this all at once so that I don't, if I do slop a little epoxy in the wrong place, it won't be in the way later on. Okay, so I've flowed a layer of epoxy in there, and that's pretty much covered up everything. I see a little bit of a bare spot here. We'll touch that in. Come around. And this is just going to seal up any little cracks and crevices. It also fills up the little holes that we put in there for our string. Alright, and then I've put some epoxy around the motor mount there. And I've already roughened up the motor mount side, and then on this ring here you can see where I've roughed that up with some medium sandpaper as well. And now I'm just going to press this on. Give it just a little bit of a twist if I can. Actually, it doesn't want to twist, so it's on well. Alright, and now we'll just wait for that to harden. And we'll do a little bit of test fitting of the motors before we go on, but I don't expect any problem there. And then our next step will be to put on the external fillets. Okay, and on some of these you can see a little bit of a sheen there of epoxy, and that's coming through from where we flowed it down. That's actually a good thing. That means our epoxy is getting in where it needs to be. Okay, so my epoxy has hardened, and we've got a nice even seal all around the aft end there, and you still see the shock cord in there. I'm going to poke that forward, so I'm just going to test fit a motor here. Okay, and then we'll just stick this on. Alright, so it fits just like that, nice and easy. Okay, so that part looks good. And then this is a 29 to 24 millimeter adapter. We'll just see how that fits. Mainly I want to make sure that I don't bottom out the threads. And that's fine, Okay, so the next thing for me to do is to put in the fillets here on the exterior part of the fins. The epoxy on the motor mount has finished hardening, and now I'm going to start in on the fin fillets. Now, some people like to use a paste type epoxy to get a really thick fillet and build that up, and so it kind of, the whole fin structure then kind of smooths into the body tube. And this works better on larger rockets. You could do it on this, but I'm just going to use regular 5-minute epoxy and just smooth it right into the joints here. I'm not trying to get a big built-up fillet here. Now, it's going to be handy to have some rubbing alcohol here, because when we go to do the fillet, I'll coat my fingers of my gloves in the alcohol, and that will keep the epoxy from sticking to my gloves so much. Alright, and just for safety here, I'm going to take this out so I don't accidentally glue it. And then I'm also going to put some masking tape around the threads here, again, just to keep epoxy out of that. Okay, so I've got my masking tape on, I've got some epoxy mixed up, not a lot at once, and I just repurposed this box because what I want to do is glue facing fins at a time. So I'm going to do this one, and then the one on this side. And I don't need a lot in here. This isn't a big high power rocket. It's, even though it's fiberglass, it's still a relatively small area that needs to be epoxied here. And if we get too much, it just means we'll have to have a lot of excess that comes off in the fillet. Okay, now for the really tricky part. So have some paper towels or tissues ready so you can wipe off your gloves readily. And as I said, you want to have a little bit of rubbing alcohol available. So now I've got alcohol fingers. And now I'm just going to smooth this out, kind of like what you would do with a model rocket if you were using wood glue. Okay, and even that was more than I really wanted. So let's try and get rid of some of this excess epoxy here. That looks better. Okay, now I'm going to get a little more here. And just backfill that. Clean off the gloves again. I'm going to try this one from the back and come up. Okay, so I'll keep this in mind when we go to the next fins. This was actually a little more epoxy than we needed. Okay, I'm going to get some alcohol on a tissue here and use it to wipe off the excess. Okay, and this is where people would usually use masking tape so they can just peel up and remove the excess that way. The epoxy on my fin fillets has cured overnight, and they came out really well, nice and smooth. These fins aren't going anywhere. And then I've also drilled two 3/32 inch holes into the airframe here, right at where two of the centering rings are. The idea here is to use the centering rings as some additional structural support. And I've got then the rail buttons and a number 8 wood screw. And so I'm just going to use the screws to tap themselves into here. Now I'm not going to make this permanent yet because I'm going to pull these back out and then paint it. And then after the paint is done, I will epoxy the screws in. Okay. When you do get these in, you want them snug, but just loose enough that the rail can actually turn in there. That will give you a little less friction as the rocket comes off the launch rail. And again, these launch buttons are not included with the kit, so you'll need to get those separately. So I opened up the Python kit, and this is the nose cone from that. It's actually a little bit longer than the Viper kit's nose cone, but I went ahead and ran both of them in simulation and found that the Viper kit actually flies better with the Python nose cone because it shifts the center of gravity forward and we don't have to worry about nose weight in it. When we do it the other way, if we put the Viper nose cone on the Python kit rocket, it doesn't change its aerodynamics too much because the Python has a longer body tube than the Viper does. So I think what I'm going to end up doing is go ahead and putting this onto the Python, giving it the shorter nose cone, and it's still got the fancier threaded rod and eye bolt system here that allows me to take apart the entire thing. And then on the Python, or excuse me, on the Viper, I'll put the Python nose cone and mount this pretty simply, although instead of putting the bulkhead flat up against here like this, I'm going to trim this down a little bit and actually mount it inside a little bit so that I've got more space inside the body tube for the recovery system. And the goal I'm working toward is to be able to put a 3-grain Cesaroni motor case in here that would allow me to fly at least the smaller H engines with this. Structurally, this rocket is pretty much done. Now, something I found when I started test fitting everything was that it's really crowded inside here. And so, mostly because of the space that the shoulder takes up. So this is a pretty big shoulder there. And so it's down to here. The eye bolt here takes up a lot of space as well. Now, if you build this where you just put this all together and glue it, this wouldn't take up as much space. So part of the reason this eye bolt takes up more space is because of my threaded rod and the coupling nut here. But that only leaves about this much free space in the body tube for the parachute and the shock cord and such. And this means that if you use an engine that is longer than the actual motor tube there, it's going to be sticking up into this space as well, and that will decrease further the amount of space you have for your recovery system. Okay. Doesn't mean this won't work, but it is going to limit. I did run this through RockSim to do some simulated flights, and basically you're limited up to a G motor here. Any of the H motors, the true high power motors, they stick up about this far into the body tube. Now, what can we do to save some space? Well, one is to not do what I did here. Okay, and as I mentioned at the beginning of this video, there are lots of ways that we could have put this rocket together, and we've explored some of them. I've rejected some of them. But one thing that could be done here is to simply not do this threaded rod up through it, and instead just glue the coupler into place and put the regular eye bolt in here. And so that would save probably at least 4 centimeters there, that you'd have more room up here for. And also there would be more room around the eye bolt that things like the shot cord can kind of wrap around and stuff up in there. Okay. If you still wanted to be able to access the nose cone, it's in there really snug now, what you can also do here instead of the threaded rod is, instead of gluing the top part here in, is put in some reusable plastic rivets or some small screws to hold this on, but not permanently. Okay. Another option would be to essentially put this in backwards. Okay, so put the eye bolt inside here so that it's hanging down in here. Glue this part on and stick it up into the nose cone. Okay, now I'm not going to shove that in there, it'll probably take a lot to get it back. What this would do is open up this whole space for additional material, shot cord, things like that. The thing to watch out about that, though, is that sometimes if you have a space up in here that you're using, when the ejection charge goes off, it can jam everything up in there and it may not deploy properly. So that's something to be aware of as well. Okay, now most likely what I am going to end up doing with this is taking another kit. Now Madcow makes what's essentially a sister ship to this called the Python, okay, kind of running along the same snaky lines. The Python has a longer airframe though, and so this type of a setup here would not be interfering as much as it does in here, simply because there's a lot more space. And I think what I'm going to end up doing is taking the nose cone and coupler out of the Python, putting it on this, and do a couple of things. One is I'm going to sand down this a bit so that it fits inside the coupler instead of on the end. Now I'm not going to go up too far. I'm going to go up basically just enough to house the eye bolt inside here, and that'll give me more space inside my body tube. And that should be enough to get an H-type motor in here. Okay, I'll just take this whole thing and put it on the other rocket, and we won't have any problem that way. Okay, the other thing here is the shot cord itself. As I mentioned, we were putting this on. This was kind of an experiment to see how well it would fit and such. And it turns out this guy takes up a lot of room. And so what I'll probably do here is actually cut off the heavy cord about here, put a loop into that, put a little glue on the knot so it's basically a permanent loop, and then I can loop a length of 300-pound Kevlar through this. Now, the nice thing about doing it this way, and believe it or not, I actually thought about doing this to begin with, but decided to go with the entire length. Having the heavier cord here inside the tube is going to have more abrasion resistance than the 300-pound would, so the edges here on the body tube are still kind of sharp, and so those could abrade a bit. This is going to give it some resistance there. And although zippering is not as common in fiberglass tubes, it's still possible, and this is going to be less likely to zipper. Now really, if you compare this to the 300-pound, more likely that you're going to cut the cord rather than zipper the tube. Okay, so these are just some options to think about. As I said, this comes as a bare bones, and a lot of what goes into it is up to you, the builder. Okay, so I'm going to leave this video here. I hope yours goes together the way you want it, and have a good launch.